Welcome to the Mental Minute, an AI-generated podcast.
Today we're diving into a fascinating mental quirk. It's called the base rate fallacy.
A mental quirk. Okay, that sounds intriguing. What exactly is this base rate fallacy?
Well, it's this tendency we have to get caught up in specific details and forget about the bigger statistical picture. It's kind of like zooming in so close on a single puzzle piece that we lose sight of the entire puzzle.
Okay, yeah, I think I get it. So how does this fallacy actually play out in real life? Does it really, impact our decisions that much?
Absolutely. It trips us up more than we realize. Let's take disease testing. For example, imagine a test that boasts 95% accuracy. Sounds pretty reliable, right?
Definitely, I'd feel pretty confident with those odds.
But here's the catch. Imagine we're using this test in two different populations. One population has a 40% infection rate, while the other has only 2%. Even with the same highly accurate test, the meaning of a positive result changes dramatically.
Wait, really? How can the same test have different meanings?
It all comes down to the base rate. The base rate is the prevalence of the disease in each population. So in the high prevalence group, a positive test is usually accurate. You can be over 93% sure you have the disease. But in the low prevalence group, a positive test is actually more likely to be a false positive. Your chances of actually having the disease plummet to about 29%.
Wow, that's a huge difference. So even though the test itself is the same, the underlying prevalence of the disease completely changes how we should interpret the results.
Precisely. That's the base rate fallacy in action. We get fixated on that 95% accuracy figure and forget to consider how common or rare the condition actually is.
Okay, I'm starting to see how this could be a problem. But how about something a little more concrete? Got any real-world examples where this fallacy really matters?
Let's talk about a hypothetical city that installs a state-of-the-art terrorist detection system using facial recognition technology. They claim it has a 99% accuracy rate. Sounds impressive, right?
Absolutely, 99% accuracy. I'd feel pretty safe walking around that city.
Now imagine the alarm goes off and flags someone as a potential terrorist. What are the chances that they actually are?
Well, with 99% accuracy, I'd say it's pretty much a sure thing. Maybe a 99% chance they're actually a terrorist.
That's what most people would assume, but it's far from the truth. The actual probability is drastically lower, closer to 1%.
Hold on, how can that be? A 99% accurate system only has a 1% chance of being right in this scenario.
Remember the base rate. We're talking about a city with millions of people and statistically very few actual terrorists. Even with a 1% false positive rate, the sheer number of non-terrorists will generate thousands of false alarms. These false positives completely drown out the true positives.
So the system might be highly accurate at identifying terrorists, but it's also highly inaccurate at identifying everyone else. And because there are so many more everyone else's, those inaccuracies skew the results.
Exactly. We get fooled by that impressive 99% accuracy figure without considering the base rate, the actual prevalence of terrorists in the population.
This is mind-blowing. So even with something as seemingly objective as a high-tech security system, the base rate fallacy can completely distort our understanding of what's actually happening.
This isn't just about numbers. It has real-world consequences.
Okay, you've got my attention.
Okay.
What kind of consequences are we talking about?
Well, think about medical diagnoses. A doctor might see a patient with symptoms that could point to a rare disease, but they have to consider how prevalent that disease is in the population. Otherwise, they might misinterpret the symptoms and make a wrong diagnosis.
So it's like even if the symptoms seem to fit, the doctor can't jump to conclusions without taking into account how likely it is for someone to actually have that rare disease.
Exactly. It's about balancing the specific information with the broader statistical context. And this fallacy can also pop up in legal proceedings, sometimes with devastating consequences.
Oh, wow. I'm all ears. Give me an example.
Okay. There's a tragic case in the UK, the Sally Clark case, that highlights this. Sally was wrongfully convicted of murdering her 2 babies because an expert witness used flawed statistics about sudden infant death syndrome, SIDS.
How did statistics lead to a wrong conviction?
The expert claimed that the chance of 2 babies in the same family dying from SIDs was incredibly rare, about 1 in 73 million. And he used this figure to argue that it was much more likely Sally had murdered her children.
That number sounds incredibly convincing. I mean, 1 in 73 million? That's almost impossible.
That's how it seemed to the jury as well. But the problem is that statistic was based on the assumption that SIDs cases are completely independent of each other. In reality, there can be underlying genetic or environmental factors that make a family more susceptible to SIDs.
So the expert was ignoring the base rate, the actual likelihood of multiple SIDs cases in families with those underlying factors?
Precisely, he focused on the shockingly small probability of two independent SIDs deaths and neglected the bigger picture. This case tragically demonstrates how ignoring base rates can lead to miscarriages of justice.
That's heartbreaking. It really underscores how important it is to be aware of this fallacy. So how does this play out in our everyday lives? Does the base rate fallacy affect our everyday judgments and decisions?
It affects us more than we realize. Think about how we form opinions about people or groups. We might hear a story about someone behaving badly, and then make sweeping generalizations about everyone in that group, even though statistically that's probably not accurate.
So if you hear about one bad experience with a certain type of car, you might assume all cars of that type are bad, even though there are probably millions of those cars on the road with no issues.
Precisely. Or you might hear a story about someone from a certain profession behaving unethically, and then assume everyone in that profession is corrupt. We let those vivid anecdotes overshadow the actual base rates.
It's like we're letting those single puzzle pieces define the whole puzzle. So how do we avoid falling into this trap? It feels like our brains are almost wired to make these kinds of mistakes.
Yeah, you're right. It's a natural human tendency. But by being aware of the base rate fallacy, we can at least start to challenge our own thinking. First and foremost, we need to be aware of base rates when we're evaluating probabilities. Don't just focus on the specific details, look for that broader statistical context.
So if someone throws a statistic at you, don't just accept it at face value. Think about the bigger picture.
Exactly. And don't be afraid to question assumptions. Ask yourself, are there alternative explanations? Am I letting a vivid story cloud my judgment?
It's like becoming a detective for your own mind, always looking for clues and evidence.
I love that analogy. And finally, seek out and consider broader statistical data, not just anecdotal evidence.
So don't just rely on those attention-grabbing headlines or personal stories. Dig a little deeper. Find the numbers.
You got it. By being more aware of base rates and thinking critically about the information we encounter, we can make more informed decisions and avoid falling prey to the sneaky fallacy. It's all about remembering the bigger picture and not getting lost in the details.
This has been such an eye-opening conversation. It's amazing how such a seemingly simple mental quirk can have such a profound impact on our lives.
It really highlights the importance of critical thinking in a world overflowing with information. We're constantly bombarded with statistics, stories, and opinions, and it's up to us to sift through it all and decide what's actually true and what's just a clever manipulation of our perceptions.
So maybe the key takeaway here isn't just about the base rate fallacy, but about learning to think for ourselves, to be more discerning consumers of information.
Absolutely. And I'll leave our listeners with this thought. What other areas of your life might be influenced by the base rate fallacy? It's lurking everywhere, from the news we consume to the judgments we make about others. So stay curious, keep questioning, and always remember the power of that bigger picture.
This has been the Mental Minute. Thanks for joining us.